What started out with a few 3D printed frames along with some Arduino shields shown in several of the past videos has now evolved in a complete and customizable low-cost DCC command station with features comparable to top-of-the-line commercial products. Let's have a closer look. Welcome to the IoTT channel. I am Hans Tanner. A special welcome to all new subscribers and welcome back to everyone else. I'm happy you made it here. DCC EX is a great command control system, but quite some model railroaders hesitate to use it because they are not sure they have the technical skills to install and configure a command station themselves. And looking at the DCC EX web page seems to suggest that these concerns are justified. There they distinguish three levels of expertise, so-called conductors, tinkerers, and engineers. And when you then read through the initial assembly page written for conductors, you see pictures like this and instructions that require you to make modifications to PC boards by cutting some traces and bending some pins. All that is not really hard to do if you have some experience with electronics, but a real hurdle for people who just want that stuff to work without knowing the details about why it works. And that's probably the majority of us. To fight this problem, I have identified four key areas that need improvement to make DCC EX more compatible with the needs of mainstream model railroaders. These four areas are simplicity, connectivity, performance, and aesthetics. Back in video number 110, where I talked about these four areas in some more detail, I reported some progress in all four of them, but I was not completely satisfied with the simplicity part. In the meantime, I have finalized the design process of the last missing element, which was crucial for creating the flexibility and scalability of the final system, as I will show you in a minute. That last element is the DCC AUX Shield, which features a 5V step-down converter which basically eliminates all need for pin bending and trace cutting and allows you to supply the DCC EX system with one single power source of up to 18V DC and a maximum current of 3 amps, which is sufficient if you are using the standard Arduino motor shield. The onboard buck converter creates the 5V supply voltage for the Arduino and other connected shields and bypasses the onboard Arduino voltage regulator, which creates a lot of heat if the supply voltage is higher than about 10V or so. Because of that, the voltage on the V-in pin of the Arduino can go up to the specified limit of 20V, which then is your maximum track voltage, without causing any harm to the Arduino. Besides the buck converter, I added some more functionality to the board, which I will explain you in a minute as I go over the resulting configuration options for a command station. If you are a Red Hat Shield user, you may wonder how the DCC AUX board compares to the DC-DC converter mounted on the Red Hat Shield. It in fact is the same principle, and if you already have a Red Hat, you don't need this new board. On the other hand, if you plan to buy a Red Hat, you will need the DCC AUX board as well, as the Red Hat starting today ships without the DC-DC converter and uses the DCC AUX board instead. So let me show you how you can use the various boards to configure a command station that fits your needs. The first step is selecting the processor board. You can choose between the Arduino Uno and the Arduino Mega. The obvious difference is the number of I/O pins that are on the board. If you plan on using them, you are probably on the tinkerer level and like to play with electronics, so go for it. It is certainly a good choice. The less visible difference between the two boards is the type of processor and the available memory, which has an impact on the number of trains you can control simultaneously. On the Arduino Uno, this number is set by default to 22, while on the Mega the default value is 50. On both boards this number can be increased, but it requires recompilation of the software, which is not complicated but probably not everybody's favorite task. For the purpose of this demo, let's choose the Arduino Uno, but everything going forward is identical for the Mega, so no worries. Next I add the DCC AUX board, and on top of that comes the Arduino motor shield board. The motor shield on the top has the advantage that the terminal screws are easily accessible if I want to change the track wiring. Other than that, the position of each board in the stack does not matter at all. And with that, the build of the basic command station is complete. No cutting of a PCB trace or bending out of pins. I simply connect a DC power supply with a voltage suitable for my modeling scale, and the command station starts up, provided the DCC EX software is loaded onto the Arduino board. To control the basic setup, you can connect a PC via USB and then use software like JMRI to control the locomotives on the main track or to program CVs on the programming track. Both tracks are connected to the outputs A and B of the motor drive board and are supplied from the DCC AUX Shield with whatever voltage you use to power the shield. If you want to make your command station look pretty, you can add the IoTT cube enclosure frames, starting with the cube base for the Uno or Mega, then adding the base frame once the Arduino is placed, the DCC AUX frame after placing the DCC AUX board, and the motor shield frame after installing the motor shield. On top of the stack you place the blind cover, either the slotted version if you would like to access the I/O pins, or the closed version if you do not want to see the pin headers. All enclosure parts are available in black, translucent red and clear, and you can combine them as you like. Or even better, you download the enclosure design files from Tinkercad and print the enclosure parts in the colors of your choice. By the way, using the enclosure frames has the nice side effect that it becomes much easier to stack up the PC boards on top of each other, as the frames provide a certain guidance and it becomes easier to plug the pins into the pin headers of the lower board. Now you have a working command station, but most likely you are looking for more. Maybe you are not happy with having to use a computer to run your trains. Or the 2 amps track current available from the motor shield is simply not enough for powering all the locomotives on your layout. So let's have a look at the available options. There are 2 communication options and 2 power options available. The first option on the communication side is adding an IoTT stick to the IoTT stick interface of the AUX board. To do so, you swap the motor shield and the AUX board so that the AUX board is on top of the stack. You now add an IoTT stick to it. This is really the easiest way to add Wi-Fi to the command station. No need to install a Wi-Fi shield and configure it to work with the other boards. Simply connect the stick and everything is ready to go. Use a web browser or your smartphone to open the configuration page and select Loconet Loopback as command source and Red Hat Shield as function hat. Then activate the checkboxes for the servers you want to make available. Select Loconet over TCP if you want to access the command station from your computer using Wi-Fi, or if you want to use distributed modules like the green hat servo decoder to set your turnouts, or the yellow hat input module to connect block occupancy detectors, etc., and then report the status back to the command station or computer. Activate WiThrottle server if you plan on using your smartphone to control the trains using smartphone apps like WiThrottle for iOS or Engine Driver for Android. And activate the MQTT gateway if you want to connect to an MQTT broker, either to access your layout from everywhere in the world or for adding functionality using software like Node-RED, for example to exchange information between the command station and your home automation system. Once an IoTT stick is added to the board, you can also solder a NeoPixel chain to the board and connect a string of WS2812 LEDs to model signals, blinking lights, block occupancy indicators, and so on, all fully configurable. The second option on the communication side is adding a Red Hat Shield on top of the stack, which in addition provides a wired Loconet. Simply place the Red Hat Shield on top of the DCC AUX Shield and place the IoTT stick on the Red Hat. Then make one external connection from the motor shield to the Red Hat to supply DCC power to the Loconet B connector, where you can connect additional boosters to power individual sections of your layout. With this option, you can use any cable-based Loconet device together with the command station. You can add Loconet-based block detector modules, radio transmitters, handheld throttles, etc., like with any other Loconet command station. Plus, the selected servers remain all active as before. On the power side, you can add a power shield to provide more track current than the 2 amps that are possible when using a motor shield. You can choose between the internal version with onboard IBT2 and the external version to connect to a separate IBT2 module. The motor shield remains in the stack and can be used as service mode programming track. So in this configuration you will have a 5 amp main track and a programming track with a current limit of 2 amps. And thanks to the DCC AUX board, you can set the power supply jumper on the power shield and the DC power supplied to the shield will be connected to the V-in pin of the Arduino board, thereby powering the entire stack as well as supplying the motor shield board. If you prefer to have 2 track outputs with 5 amps each, you can choose power option 2. For this configuration, you remove the motor shield and put on 2 IBT2 power shield boards. Again, either the internal or the external version. You then click the main signal on proc track option, and the second IBT2 board will act as second main track whenever it is not used for programming. Now be warned, whenever you send a programming command from the command station, it will switch the connected track to programming mode and program all locomotives that currently are on that track. So be careful and verify that no other locomotives are on the track than the one you want to configure. Like with the base, all additional boards can be put in nice enclosure frames to make the command station look pretty. There are separate top covers for the DCC AUX Shield with and without installed IoTT stick, and for the Red Hat as well. So whatever configuration you implement, you always can get the frames needed to make it look pretty. Or as said before, download and print them on your 3D printer. Here is an overview chart showing all available options. Starting from the base command station, power and communication options can be selected to configure the command station that meets your performance requirements. The nice thing, of course, is that you can start with a lower level configuration and then add additional options as your layout grows. On the next few slides I show you budgetary prices, which will be finalized as soon as the boards are actually available in the Tindy store. There are individual price charts for the Arduino Uno and the Arduino Mega based command station, as well as for power options using the internal or the external version of the power shield board. The external version is less expensive, but it requires an additional IBT2 module which is not included. I recommend using the internal version as it is simpler to install and connect and offers the possibility to power the entire stack from one single DC supply. Possible reasons for choosing the external versions are if you already have IBT2 modules available and want to reuse them, or if you plan to configure a maximum track current of more than the recommended 5 amps, maybe for a garden railroad. If you order a kit consisting of a base station along with power and communication options, the DCC EX software will be loaded and configured to work with the selected power options. All you need to do is stacking up the boards and the command station is ready to power up. The prices for the enclosure kits should motivate you to print your own frames based on the Tinkercad designs, which I highly recommend. The printing time for a complete enclosure for the command station is around 10 hours, so my only 3D printer quickly becomes the bottleneck of the process. And I am not really interested in setting up a printer farm, so please, if you have access to a 3D printer, print your own set of enclosure frames at a fraction of the cost and in the colors you really want. And that's it for the technical concept of the customizable IoTT Cube command station. Of course, now you ask, when is it going to be available? Good question. Well, for the power shield boards I just received some IBT2 boards and another small batch of them will be available in the next few days. The DCC AUX board is currently in manufacturing and should be here in about 2 weeks' time. I had just 5 prototype boards which I made available this week and they were gone in just a few hours, so it seems there is a lot of interest in that board as well. So over the coming weeks I expect all boards becoming available in limited quantities in the Tindy store, and once that side is more stable I will start offering complete kits, programmed, pre-configured and tested, so all you need to do is stack up the boards, add a power supply and run your trains. That's the plan at least. And that's it for this video. I hope this information was useful or at least interesting for you, and you are as excited as I am about this modular and customizable command station concept. If so, please click the like button below to let me know, or leave me a comment in the comment section of this video. I really like to hear from my viewers, and all feedback also supports the IoTT channel, as it motivates YouTube to suggest this video to other model railroaders. Thanks for watching and see you in the next video.